Okay, so today I'm going to give a 45-minute overview of how to secure your applications. I recommend using OpenID Connect and OAuth. There's lots of other ways of securing your applications as well, but it's if you stick to the standards and use best practice things that you know that work, you're not going to have problems usually. You could still have them. So, two things I want to talk about. One is what you have to secure today, how applications look these days. It's no longer just a single application, but many applications. And then which flows and how you should secure this using OpenID Connect and OAuth. So typically, what you have nowadays is you have maybe 1 or 2 UI applications, 10 UI applications. You have loads of different things. You've got some APIs you want to consume. You have some in the protected zone, you have some in the public zone. And the first thing to know is that you should always make a security architecture if you have a public or the private zone. So one of the first things you can look at this diagram, I have 1 user and I have 2 applications. So we don't secure a person, we secure an identity. And an identity is a person plus the application. So this person with this application is 1 identity. This person with this application is a 2nd identity. And I can trust the 1 identity with the back end, the server end application more than I can trust the one in the public view because it's not trustable, the client application. So you don't secure people, you secure applications and people together. So if I was to do this now, I use my web application firewall and I push it back a bit. This is way less secure as before because, for example, now I've got a resource server in the public zone, which means that that's attackable. I have this application that no longer has a trusted backend. It can no longer keep a secret. So this will be a single page application. So I have to treat it different and secure it differently. So it's less secure or has more possibilities to attack. So I always say as an application developer or architect, whatever you are, what do we need to solve in a solution? So you usually have to have a solution for authentication, authorization, and accounting. We don't usually implement this ourselves anymore, but we have to solve it. Session protection you need to solve. Certificates you have to do right. Hosting is really important. If you use a bad hosting environment, you're going to have lots of security problems, or you have to reduce your application security because you got a bad hosting. So it's really important to do good hosting. GDPR is something we have to implement. For example, the right to delete and stuff like that we have to support, but most of the processes is not our job. And of course, web application firewalls. So as a solution developer, or something we have to deliver solutions, we usually concentrate on the top 2. We have a bit to implement in all the middle bits, the hosting. We don't always have full control. Sometimes we do. And the web application, we usually have nothing to do with that. And that's changing because now we're deploying to Azure or AWS now. And what happens an awful lot nowadays is that actually you have to deploy the whole thing as code, infrastructure as code, and then we are developing the whole solution, not just deploying it to some hosting environment. So for me, typically what happens in a web application or you open up an application, usually what happens is you open the application, and then at the very start of every session, you have to authenticate and authorize usually, mainly authenticate. And we have certain standards and ways of protecting that. And then once you're authenticated and authorized, then the session begins. And then we use different tools, different mechanisms to protect the session. So you have to protect that differently to the session at the end. And really important is to sign out. That's really hard to do properly. We have different ways of implementing secure ways of logging out. Do you have to log out just to the application? Do you have to log out if you do a federated logout? Do you have to do a back channel logout, front channel logout? Is that everything log off, or just you delete the cookies like Google tries to force you? There's many different ways of doing this. So no matter what you do, always just use a standard and don't implement this yourself. Because anytime I do a review or see something going wrong in applications, it's nearly always that someone has reinvented the wheel and made it themselves. So if you just use a practice and use a standard best practice, you're already doing not so bad. So the 2 standards I recommend now always is OpenID Connect and OAuth 2. So OpenID Connect came after OAuth 2. OAuth was, when OAuth 2, it was just an access or authorization delegated protocols. It's lots of standards and definites how you can access a resource. And the problem was then there was no standard way of authentication. So every company implemented the authentication themselves. So they came together and made standards, so loads of standards now, which is authentication on top of authorization. So it does both. You have authentication and authorization. So OpenID Connect implemented the idea of identity, plus a standard way of getting the user profile data. So what is OpenID Connect? It's a standard, it's a specification, it's not an implementation. It does authentication and authorization. Everyone knows what authentication is, I assume, so hopefully. And then it's built on top of OAuth 2. which is access control. OAuth 2 has improved lately as well. There's lots of new standards which also they're starting to move together, and there's lots of really cool things happening in the OAuth 2 world. And then you have an identity, and each person can have many identities. What's so cool about OpenID Connect is why I recommend this. If you're producing applications, nearly any of the services support it. So if I deploy to any software as a service, any cloud, I want to implement this myself, I can more or less deploy that without any problems. I can just almost plug it in. You just have to define a client and it works. So if you're using OpenID Connect, you can authenticate or use the IDP, Azure AD, or Azure B2C. They don't do it super, but they do it fairly good. OAuth or the Okta. Okta is not so good lately, I read. OpenID Identity Service if you want to implement yourself, or Keycloak is a self-implementation. And then what's really good one, if you're into Node.js, Node OpenID Connect provider has all the latest and best practice from standards if anyone programs Node.js. It's a really good one, actually. So what does it solve? So you see, OpenID Connect and OAuth protects the start of the session, and it also protects at the end of the session. It doesn't help you anyway in the middle. You have to use different protection standards and different tools for that. For example, you have to make a CSP, or you have to use your security headers, or you have to protect your database from the typical attacks. Protecting the session has nothing to do with OpenID Connect or OAuth. It's only at the end and at the start. There's lots of really good standards for both. So the rest of the talk, I'm going to say which flows are possible and which ones you should use for OpenID Connect and OAuth. And the idea is that if you can just from any takeaway from this talk is that, you know, I'm having my application, it has no user, it has a user, it's protected, it's not trusted, I should use this flow. And then if you know, because you're not going to remember an awful lot, usually you take away 10 minutes, 20 minutes, but if you know, okay, I'm doing this type of flow, I should use one of these flows, and then you can go check in Google and say, okay, I'm going to server-rendered application is the best and try and secure it this way. So these are the flows I use at the moment, and I nearly have no application that doesn't need any of them. So two of them is the first one is app-to-app resource owner credentials flow, and Azure Managed Identities I use as well. They're the same thing. You have app-to-app with no user. Then the next three is trusted backends, where you have PKCE proof key of code exchange, and you have a secure backend which can keep a secret, and I trust application, and then I authenticate the user and the application together. Then you have two special ones. The one without a PKCE, you have no secret. That's for all native application, mobile application, desktop applications, console applications. And then the device flow is where you have no user input. For example, a PlayStation, an Xbox, your TV, your EOT devices or machine, whatever you have. So before I explain the flows, just some things you should know about. What's an ID token? So an ID token is what I give to the application. And in the application, it's everything in it that I need to, if I'm a trusted backend, I can use it for my authorization maybe. If it's not a trusted application, I can use it for UI. And it's a self-contained JWT token with everything in it I need that I get back from the authentication process. Now, you don't have to put everything in it. You can use the user endpoint, but it's something that you open up in your application and you use it. The next two is tokens, the access tokens. You never open up an access token in your application. Access token is only given to you as a UI application. They pass it on to the appies. The appies use the access token. You don't send the ID token to an appie ever. There's two types of access tokens. One is a reference token and one is a self-contained JWT token again. And the difference is that the problem with a self-contained JWT token is you can never invalidate it. It remains valid until you expire. So if I click the logout button, those access tokens are still valid. So if I was to rob your access tokens, even if you're logged out, I can still use them after. And you can prevent that with a reference token, because with a reference token, it's a reference of an access token which never uses this trusted backend. And then when I send my reference token to the appie, it can use introspection to get the claims and the data for that reference token, and then it can give you the data back or not if it's valid. And what you can really do is then with a reference token, I can invalidate a reference token using the revocation endpoint, and I can say this reference token is no longer valid, and then I can kill the session. Now, Microsoft don't support this in the Azure AD. They do continuous access evaluation, but you cannot log out with that. So this is, if you're using single page applications or public, I always say use reference tokens, revocation if you can. Not all of them support it. Then refresh tokens is really important. You don't want to log in every hour or every 2 hours when your tokens expire. So you have a mechanism called a refresh token, and using the OpenID Connect standard, you can request an offline access scope. It will give you back a refresh token then. Some of them give you back the refresh token anyway, even if you don't request that anymore. And you use a refresh token now to continue on the session. But the refresh tokens are dangerous because once I have a refresh token, I can stay logged in pretty much forever. So you have to be really careful how you store and save the refresh tokens. It's really important. So when you're using refresh tokens, you have to use the protections that's required. So the flows I want to talk about. The first flow you need to know, I think, is for OpenID Connect, or not OpenID Connect, OAuth to resource owner credential flow, the CC, a lot of people say it. And this is only for a trusted application. So to use this flow, I have to keep a secret. So I cannot use that in a desktop application. I cannot use it in a console application. That's really important. A lot of people run a console application on the VM, and that's really dangerous because you're sharing the secret. So this is only for a trusted application. There's no user. It's machine to machine. That's like app to app. There's no person. And it's really simple, actually. All I do is I do a token request. I say, I give you the secret, and I say, this is the client ID. Can you give me an access token for that, please, with this scope? And they say, yeah, that's fine, and they give it back. So the problem is here, if I steal this secret, or I can use a certificate as well, it doesn't matter. You don't know who is requesting the access. You just know that it's valid. So you cannot validate who sent you that. All you know is that it was correct. You gave me the correct credentials. Yeah, you can have it. So you have to really be able to trust this client application. And then if I get the token back, then I can access the API, and then I have access to it. So yeah, you have to be very careful. You should only use this in a trusted environment. The next flow, I'll just check my time. Time seems gone off. So the next flow I'd like to talk about is the OpenID Connect Authorization Code flow with PKCE and with a secret. So this is what I use pretty much everywhere if I can. This is the safest flow, and it's a user interaction flow. I validate the client and the user and the identity using it. So I authenticate both. What's really good is a two-step authentication process. And the way this works, I'll explain the PKCE after. What happens is when I open up my browser, from the front channel that's in the browser part, I do a request to redirect to my OpenID Connect server. That could be anything. And then if the request with all the parameters are okay and valid, what I do then is I do a login, I do authentication, I use my FIDO2 key, I validate two-factor, everything's correct. Then I give my consent that it's okay for me to use this application. And if everything's okay, I redirect back with a code. Now, what happens with this code, then we have to protect that as well. That's why we need the PKCE for this. But I redirect back to the code, and then I go to the back end of the application. I send this with the secret that only the application, my trusted backend knows, plus the code, and I send that to the server again. The server then checks that the code is good and the secret is good, and then gives you back the tokens that you requested. So you get an ID token and an access token back usually. If I request the offline access scope, I'll get a refresh token as well, and then I store this in the backend. So this is all done in the trusted backend, nothing in the UI, nothing in the browser. Then you can also request a user info endpoint, because maybe I have lots and lots of claims for each profile. You do not want to put all your data into an ID token, because then it will get really big. So you can use the user info endpoint. You can request the user info endpoint, and then you get the data back as well. So it's really simple. It's a two-step validation. You do first step is to redirect from the front channel. Second step is then to request here from the back channel. So it's a very simple flow, and it's the safest and the best practice recommended for most of the OpenID Connect flows now. There's lots of mixtures of this, even just that flow alone. There's lots of things added on. You can use different features and different extra security protocols on top, but most of the times you're using something like that. This is what I use pretty much for every application if possible now. So a very similar flow is the OIDC, the hybrid flow. And this works almost the same. It's just a little bit less complicated, less safe. And the main difference here is the flow starts off exactly the same. You do authorization request, and you do your login, your consent. This time when you get the code back, you get an ID token back as well. And what's good in the ID token is that I can start up the application straight away down here using these claims. I don't need to wait for the next request. And then also what's good in the ID token, I have a thing called the C hash claim, and I can use that to validate that sending the secret here. So just like I was to rob the code and put it into a different application, I could send your code with my instance, and then I can take over your session. Because I have a C hash in the ID token, I can validate that the code that I have is the same as the first request, because I need to make sure that the application that sent the first request is the same as sent the second request. And we're using the C hash that can validate as the code before I send it, that it's sent correctly, and then I get the tokens back the same way. So you don't need to use the PKCE for hybrid flow, but if you do use it, it's fine and it's good. You have an extra layer of protection as well. So you don't need this flow anymore either, because you can do everything with the code flow with PKCE as well. So it's just another way of achieving the same thing. Then the next flow is really important. It's a native app, single page application, desktop applications. This is an application where I do not trust. It's somewhere on your browser, somewhere in your deployment. It cannot keep a secret. So it's a public client, and you have to treat it that way. So one of the problems is because I cannot keep a secret, or what was happening on mobile devices, that when I was getting the code sent back to your mobile device, people will have their kids' games installed or whatever, and they were robbing the code before you got it. And then what they do is they send the code back and they take over your session then, and then they log in your banking account using this. So the code was getting robbed on the second step. So what they did, they came up with a process called the PKCE Proof Key of Code Exchange, which prevents that. So what I do is, before I send the authorization request, I create a string. It has to be a certain length, and then I hash it using one-way encryption with S256 or something. And then I send you the hash along with the authorization request. So it's a differential or an integrated differential of it. And then I save that on my authorization server then. And when I send the second request, then I send the original string. And then what the server does, it does the same encryption and the hashing, and then it checks if the hashes match. And if the hashes match, then I know that the application that sent the first request is the same as sent the second request, so it cannot rob your code. So it's a really simple process, and because it's so useful, you can use this for all your applications now for any two-step authorization. So every single public client has to use PKCE if you're using CodeFlow. And everyone uses CodeFlow, so you have to use PKCE. So single-page applications is the biggest problem at the moment. Problem with single-page applications, it's not possible to keep a secret. You have a local session or your session storage or local storage, and this is something that's accessible from JavaScript. So if I can rob that, then I can take over your session. So it's really hard to protect a single-page application. And that's a huge problem, actually. And people say, okay, I can use a web service now, and you cannot see the web service from JavaScript, but the JavaScript still needs to access that to send the HTTP request with the bearer token. So you're not really any safer, you just make it a bit harder. So the biggest problem with single page applications is, where do you store the sensitive data between the API calls? And the best way to protect it is actually you don't implement a single page application. You do a server-rendered application. And one way of doing this, because everyone loves to do Angular or React or all these new cool technologies, one way of doing that is you can use the backend for front-end architecture, which means is that your Angular application or React or whatever you do is just a view from your backend. And then what I do is that every single request, then I send a cookie, and then the APIs that I can use in the backend is same domain protected. You cannot switch the domains, and you have all the security implemented in the trusted backend. So that's the best way, because then I have no sensitive data in the front end. And the big problem with that is that if I have an API on a different domain, I cannot access that. I have to go to the back end, and then it does a reverse proxy, and it goes to the other API, get the data back, and then comes back, and it comes back. So you're doing 2 API calls instead of 1. But it's a good trade-off if you wanted to have the maximum security. Another way of doing it is that you could just do the API call in the back end, or you don't have any API calls. You only use the same domain, because maybe we're over-engineering everything when we're doing our microservices. Maybe you don't need to have 1,000 microservices. Maybe one solid monolith application is way better. At least you can secure it properly, and then you don't need Kubernetes and all that stuff. So I say the best way to do a single page application is to not implement a single page application, do back end for front end architecture if you want to use one of the front end technologies, which are really cool, that you can do really productive and cool stuff with it. If you're using cookies, then secure your application, you have to make sure same site is in. You have to still support old browsers, so you need some type of anti-forgery cookie protection. And then, of course, you need the HTTP headers and all that type of stuff. And then you have to secure your logout. What's really cool, if you have a logout scenario, single sign-on or multi-sign-out or federated sign-out, you need to be able to log out. And to do a proper logout, you need a backend as well. Because, for example, if I have a logout and I have 5 different UI applications, the front-end applications aren't always online. And how do you tell them that I want to log out from there as well? So you have a multi or a federated sign-out. It's not possible. You can only do that with a back-channel logout. So it's, if you have a complex architecture where you need to do a proper sign-out, then you need a backend everywhere. Just say it's not possible to implement the backend, then you use the CodeFlow with PKCE is the recommended way now. And implicit flow is no longer recommended, but it's not really much less secure than the CodeFlow with PKCE, because the problem is you're storing the tokens in the session storage or local storage, or your web worker, which is hidden a bit, but it's still accessible from JavaScript. So that's the flow then you need if you need to do quick applications with access to APIs from different domains. And there is an awful lot of protections in Azure AD. They have extra ways of protecting the extra layers and stuff. You can reach a relative high level of security with that, but you're still storing the sensitive data in the browser, and that's the problem. And of course, then the implicit flow is no longer recommended, but if you're using that, it's not really much worse than the other one. The only problem is that when you redirect the first API call, you have the access token in the URL, and that gets persisted in the admin logs and all that type of stuff. So SPA is a front code flow with PICs with no secret. It's for single-page applications. The client is not authenticated. The response type is code. There's no secret, of course. You should always use reference tokens if possible, because you want to do a logout. And then refresh tokens is the only way you can do a refresh session now with a single-page application, because they blocked the old way of doing iframe with the same protection with the new browsers. So if you're using refresh tokens in the browser, they're really dangerous. We used to say never use that, but there's no other way of refreshing the session now. So you have to add in all the extra protections that you can only use the refresh token once, keep it short-lived, renew it. When you log out, that you actually revoke the refresh token, use the verification endpoints and so on. So you have to add in the extra protection if you're using that. Now, one of the big differences, an awful lot of people like to say I make an Angular application, then I use Cordova and I produce a mobile application. There's actually a few differences. It doesn't always work. The biggest difference is that when I have a single page application, I just redirect from the browser to the IDP, and then I redirect directly back. Everything's in the browser. When I have a native or mobile application, you have to open up a browser UI, and then in the browser, then I redirect, and then I come back. And then the redirect URL from the browser from a native application is some standard Android or some standard iOS URL. I cannot validate that really, because everyone can use that. So it's really important that the redirect that comes back, then you have to store your tokens in the application, and it has. So you use a different URL depending on the host system, and then you have to open up a browser. If you have a mobile application where you have no browser doing the login, just say you have a username and password directly in the mobile application, you know that's unsecure and you shouldn't use the application, because you're letting the mobile application handle your username and password. That's really bad, because then it could do a phishing attack or it could do an impersonation attack, and there's nothing you can do. You cannot protect against that then. So any mobile application which doesn't use a browser to log in, you can just more or less say it's per default unsecure. You should always use a browser to log in. And then, of course, I'm not going to trust you to handle my passwords. Why should I let that application handle my IDP passwords? And, of course, then what's good as well, native apps have the possibility to store refresh tokens safely. With a single-page application, you only have the session storage or the local storage, so it's impossible to store it safely. A native app can do that because you have a secure storage in your browser, which you can put tokens into that. So it is possible to store the tokens safely on a native application. So just to show roughly the differences, a server-rendered application, you have a back-end and you have a front-end. You have all your HTML and JavaScript. It's all just one application in the security context, not two. So this application can use no other applications. It can only use this application. If I'm doing enterprise applications as well, I block all CDNs and everything. I just say that's the only back-end I'm allowed to use. I don't use JavaScript from other Google fonts, for example. You're not allowed to use from a different place now. It's very careful. You should always self-host your Google fonts. It's the same thing with the backend for front end. This would be my single page application, but it's not really a single page application. It's just a view from my backend API. Everything is hosted in the API. My security is implemented in my API. I force same site HTTP only cookies. And then what's good about this is like the JavaScript has no access to the cookies. The browser takes care of sending the cookie to the backend and back. And it's one application I secure. So I've just got one single backend secure trusted application. In this backend, then I have a secret. I can add the extra protections. I could use MTLS, or I could use whatever I want. I can do a proper logout. That's a good way of implementing a JavaScript application, which use a backend. The only problem with this is that if I have an API here in a different domain, then it's going to be slower because I have to go to the backend, reverse proxy to the other API, back and back. So you lose an extra API call. So you lose a bit of performance, but it's safer. And this is a real single-page application. You have two completely separate applications. You have the user interaction flow. You store your tokens in an unsecure place. And then you have the back-end application, which is an API. You have to make the API public as well. And then it also has to be protected. So you've got two completely separate applications. The next flow I want to talk about, what's the time like? What have we got?
12 minutes.
Oh, cool. So the next flow I want to talk about is the OAuth device flow. And this is really good if you have no proper user input. So just say you have a touch screen in your machine input, or you have an EOT device, which doesn't have a browser maybe, or you have a PlayStation, is a typical example, or a TV, and you want to log into your TV properly. And I always have a really super password now with maybe 50 or 100 characters, and then I have my multi-factor security with FIDO key or whatever. And I don't want to just give in a password alone, but I want to use the password and the FIDO key together. So what I do is then by using the device flow, I can use my mobile device, I can use my computer to log into my PlayStation without having to use a weak password. Because can you imagine a PlayStation giving in 50 characters? You just don't do it. So this flow solves this case. So it's really simple. What happens is that when I start the TV, I can touch the TV screen and say I would like to log in. You click the login button. When you click the login button, what it does is sends a request to the server. It says this application would like to log in. And then it creates a device code. And then it sends the code back to the device. And then I can produce a QR code or a URL with this code. And then I can scan it with my mobile phone, or I can give it into my computer. Then on a separate device, then I can do the login. I get the code, I log in, I do my 50-character code to my password manager, whatever I use, and then I use my FIDO key, and then I give my consent. And then when everything's okay, I've completed the login on a separate device. Then I come back then here and says, well done, you've logged in. And in the meantime, my PlayStation, whatever it is polling the whole time. Have you got proper session? Have you got validation? Have you got validation? And the next time it goes back, it says, yeah, now we have a proper session. And it gives the access token back to the TV. And then you're logged in on your TV correctly using a proper authentication. Now this works really good, but it has one massive problem, as all. You're using multi-device login. So it's impossible to protect against phishing with this. So you should never use this unless you have to. So if you have a user constrained input or whatever, it's fine. But you should never say I'm using a desktop application on my Windows. And you know this redirect to localhost is a pain sometimes because I've blocked HTTP by me, for example. And the redirect always comes to HTTP and not HTTPS. So it's actually, it's a super flow to use, but you can never protect against phishing with that. But usually for machines and stuff, you don't need to protect against that as much. It's not as much of a problem. The next flow, which is really important, especially if you're in Azure AD, is the on behalf of flow. And this is actually really handy. I'll show it actually here. The big problem is that I have a API which needs to use another API downstream. And I do not want to give this API, so this is my API, and I do not trust this web API that much. I do not want to give that authorization admin rights, because I don't want to say that can access any data from that with app-to-app security. I don't trust it. And second of all, I want to use a delegated flow from this application, and it has no access to the web API too. So what happens is that this does a normal login using CodeFlow with Pixie, whatever. You come to the API and say, okay, I want to get data from the second API. So what it does is this is the access token for this identity, and they would like to make a new access token for this on behalf of. So what it does, it goes with a secret. It says, can you give me another access token for web API 2 for this user and this access token? Then it says, yeah, that's fine. It gives you another access token back to access web API 2. And then this is a totally normal then user access delegated flow. You get the data back and you get the data back. So it's really great. You should always use this if possible, especially in Azure AD, because I do not want to give maximum security for, I don't trust web API 2 doesn't trust web API 1. I don't want to give them the full access rights. And then also then you do not need to make this public just because this API needs to use it. Some people just go direct from the API to here and back. So you can reduce the access or the attack scope. So you can also implement this with Identity Server 4. I've never tried it with Keycloak or anything else yet, but Identity Server now we say. But yeah, it should work. The last flow I think is important that everyone should use and know about is the managed identities. And this is the same as the client credentials flow. So this is just, there's no user involved, and I want to access Azure Service 1 wants access to Azure Service 2. And there's no user. So what's really good about this is it's just a special service principle. What's really cool about this is that you don't have to manage or handle secrets. You can just assign the managed identity, and then you say this managed identity has access to these resources, and you get the data back. So there's two types of managed identities, which is important to know about. You have system-assigned managed identity and user-assigned managed identities. Now, it's really important. It has nothing to do with a user. This is really app to app. There's no user involved. And what's the big difference is that a system-assigned managed identity will belong to the car, for example, in this example. So if I destroy the car or kill the car, I have no longer this managed identity, and I can no longer open the garage in the example. This comes in .NET show. And then if I was to do a user-assigned, I create a single user-assigned managed identity, and then I can assign it access to the garage, and I can then use it from any different car or anywhere. Anyone can come along and click, I'd like to access this resource. So it's really good about this. I can do one access definition, which can be used once defined here, and I can use it anywhere. But the only problem with that is that when I kill the car or destroy the car, the user managed identity will never get destroyed as well. You have to actually destroy that as well if you're cleaning up your resources. So you have to be careful using that. You don't have lots of daemon managed identities hanging around when you're cleaning up your data. But it's really handy to use. So for example, you have a limited amount of RBAC rights that you're allowed to assign to any service. So if you have maybe 50 services that need to access something in storage, you can just assign one user managed identity, and then you can use it everywhere. So it's just client credentials flow using single service principles, and there's no user involved. An awful lot of people use this for database access now as well, instead of a credential connection string. So all the examples, I don't have time to go through each example. I'd love to go into start showing you the code now. You'll find everything on my GitHub account. And if you're looking for an example of one of the flows, how do we implement this in .NET Core? How do we implement this in backend for front end? Just give me a ping me, or you'll find them all on my GitHub repository, or I'll probably have a blog about it somewhere as well. So if you want to find it, say I want to know how do we implement this flow, or when should I use this flow, just send me a tweet or a ping, or send me an email, and then you can contact me, and then I'll just show you. There's the code. I have everything is online and public, so there's examples for everything. Microsoft have really good examples for how they recommend using Microsoft Identity Web. So you go to the docs and find them. The Azure ASP.NET Core docs have really good examples for JWT implementations. They have bad examples for implementing, I think, for the how to implement non-Azure security, but the Azure solutions are really good. And then what's really interesting, that's only one way of implementing authentication, authorization, application security. What's really interesting in the other parts of security, there's so many cool things going on at the moment. So if you like learning security, it's actually great at the moment. One thing everyone should learn and use is the FIDO2 keys. I use that everywhere now, and Azure is starting to support that out of the box for everywhere. So if you're recommending a client anything, I always say just go FIDO2 keys, and then you've solved phishing almost overnight. So FIDO2 keys is the only way to log in or secure authenticate without being subject to phishing attacks. What's really interesting in Switzerland is self-sovereign identity, and Azure verifiable credentials a little bit less. It's a new security way of logging in, and they use the blockchain then to save your data. They've changed the system about that. You have they call it a verifier, a wallet, and a issuer. And the Swiss government are starting to implement a new government EID using this technology. So for us, in maybe 5-10 years, we'll be logging into all the government health systems using self-sovereign identity probably. So it's actually really interesting to read about it, but it's full of security holes. The standards don't match. There's two branches going different ways. It's like the early days of OAuth. But it's actually fiercely interesting because they say they're giving the responsibility of the data to the user, and no longer you have to ask Google, can I have my email please to log in? So it changed the flows, but it's actually cool. Certificate authentication, of course, is cool. You can use that with, on top of it, or without. You can just use it on its own. PKCE systems are cool. OpenID Connect FAPI is really interesting. Anyone to learn? That's like another layer on top of the standard OpenID Connect, which introduces MTLS and cyber, back channel logouts, and all these type of things as well. So you have extra layers of protections for banking applications or health applications. So the standards are really easy to read, and I recommend that. And what Microsoft is pushing big time is continuous access evaluation. This only works for Azure AD. They made a new standard called Connect Shared Signals and Events, and it makes a way that if I'm an IT admin, I can kill your session from as admin. Just say the typical use case to say is someone leaves the company and you need to kill the session straight away. They can revoke all your credentials and you cannot log in anywhere straight away, almost in real time. Finished? Oh, I'm going too fast then. So it always goes faster. So yeah, I have time then because I'm just finished now. That's a really fast run through all the flows. So we have 10 minutes for questions or whatever. If you want to go into detail, or I can show you an example if you want. Or does anyone have any questions, or does anyone think they know to use which flow for whatever? So for example, if I have a verification, you'd know which flow to use now, would you? Hopefully. You'd use a client credentials flow probably, which is... Okay, so yeah, I'm going to be hanging around all day today as well. Actually, I went too fast now. So what I'm going to do is I'll be around till about lunchtime, isn't it? And then if you have any questions or would like to say, how would you implement that or whatever, what I do most of my job now is I recommend solutions, how to implement security architecture. And I always say that the main thing is trying to keep it simple. So what I usually do is actually that I try and reduce the complexity, and then you can do your security pretty simply. And then you just take whatever flow. Another thing as well, if you're implementing security, don't try and take a tool from a client and then you implement the way you think's best. Use the tool the way they recommend it is usually another big help. So, yeah, that's all.
I have a question regarding identity server, because now it's not free anymore.
Yep.
What's a good alternative in the .NET community to have a
OpenID Dict is super.
Yeah.
It doesn't have as many specifications implemented as Identity Server, but Identity Server for 5 now or whatever, it costs pretty much nothing really. Think if you're doing just say you're doing a big application where you really need full control and high security, it's actually not expensive to use that, because I think the license cost is really small. I think the main cost is not the license, but the implementation. Because if you use Identity Server, you have to implement all the interface. You need the UI, you need the administrating your account, and you need a database, maybe a federation. That costs. That's maybe 6 months work to get it up and running properly with the multiple architecture, whatever you need. But if you want to use a free one, it doesn't cost the license cost, because some companies say you're not allowed to pay for one. I use Keycloak a lot now, and I use OpenID Dict. And but for me, the cost isn't. The license doesn't make a difference really. My main cost is the development of the solution. But if you want high security, Identity Server has pretty much the best and latest standards. For example, if you want to do a FAPI solution, they're the closest to implementing this in the .NET world. But OpenID Dict has strictened the standards, but there's not as many implemented. And then Keycloak are pretty much the same as OpenID Dict. We use that a lot anyway because it's abundant and the health. And then if I don't need high security, for example, just medium security, then I use Auth 0 or Azure AD. If I'm enterprise, Azure B2C is okay. It's missing loads of things as well. There's a lot of problems, but you can still do a good security solution with Azure B2C. But I try to use the cloud as much as possible, because what I know is that most people don't have a full understanding of security. So I try to delegate that away from the implementation. So if you think about it, if you have 6 months implementation, it's going to be way more than the license costs. But if you really need full control of your identities, it makes sense then to implement yourself. Then, yeah, Keycloak, OpenID Dict, or the Identity Server. I find all 3 of them good actually. And I don't really. For me, the price is no importance. It's more what do I want to do? What's the more value for my client, or where's the most? Because you think about it, as most people don't fully understand the protocols, and if you're going to implement it all yourself, you have to implement everything yourself, and you have to start thinking, how do I do this? And maybe you have the knowledge, you know the best way, then because you just OpenID Dict and extend it then as well. But what's cool is in ASP.NET Core and .NET Core, you've got the extension points everywhere. You can implement pretty much anything yourself if you want, and you have the time and the money. Does that help? Yeah.
What do you think about decentralized applications and blockchain?
Blockchain is, I think it's great and terrible at the same time. Because okay, so decentralized identities, the idea is brilliant. You have your verifier wallet and your issuer, and it solves loads of problems. Because for example, I no longer need a Google account to access my data. I get the data from, I have an issuer from University 1, University 2, and I have my health driver's license and my EID from the Swiss government. I put them all on my wallet, and then I can go to any application and log in using that. But the big problem is remember it says cross-device flows. I'm using my mobile application to log into a web application, so it's impossible to protect against phishing. So straight out of the box, you have a new problem which is not you can't protect against. So if you want to protect against phishing, you need to use a FIDO2 key, or you can use a PKCE solution as well. So it's missing security concepts as well. And then another problem with it is that the way they implement, half of the self-sovereign identity use DCOM v2, and the other half use SIOP with the OpenID Connect specification. And the DCOM v2 group have no solution how to authenticate your users, because you have your wallet. They all say just use a biometric login on your wallet. What type of biometric? Where? There's no definition. It's just you use EOS, Android, or you use this. You have to use a different protocol. And then with the SIOP, you have a solution for that, but it's no way of doing authentication properly on the issuer verifier. On the verifier cannot use authentication. You know that you're sending me a token. I don't know if it's you sending me the token. You just know that it's a correct token. I cannot validate it's actually you sending it. And the typical use case they all say is that I want to buy alcohol in the shop, and I don't need to show them that what age I am. I just need to prove that I'm old enough. So you just you go in, log in. But if I have a wallet and I have guardianship, my kids probably will use my wallet. You know how if you have kids, they just all grab your phone and they know your phone better than you. They'll use your phone to buy stuff as well. That's just normal. And then you don't know as a verifier if it's your kid sending the request or if it's you. All you know is it's the correct request. So you cannot actually implement authentication on the verifiers. Then there's an awful lot of unsolved problems. And then the specifications, for example, at the moment, there's a thing called the BBS Plus specification. And that's a way of pretty much implementing most of the verifiable credentials use cases. But most of the platforms that implement don't actually support it yet. So there's actually no platform that has all the best standard, best practice supported. And the government are building a new solution now, the Swiss government, and they're going to take a mixture of all of them, but there's no consensus, no standard that all are using. Now, Azure don't do self-sovereign identity, they call it digital identities, and they have a solution, an Azure AD, which everyone can use if you use the P2 license at the moment. And what's really good about that is you can test it, you can create a verifiable credential. I can issue a credential, put it on your Microsoft app. I have one here actually here. It's really simple to implement us on my phone. And on your wallet, everyone has the Microsoft Authenticator wallet on their app, and that uses verifiable credentials already. And you can add the credentials to your wallet from Microsoft, and then I can use a digital identity from the other side and then just use it. So you have a working solution, Azure AD, which you can already test and use. And it works very good, but it doesn't, they're all saying it gets rid of the OAuth, OpenID Connect or OAuth 2, it solves all these problems. It doesn't. You still have the authentication problem, you still have the phishing, and phishing is our biggest problem at the moment, security almost. It doesn't solve them problems, but it does help solve other problems. And there's loads of little things like, why do you need the Google email, or why do you need a Facebook email, or why do you need your company email to log in? And that's the way it works at the moment. And it's not bad, but it's not good. Another problem with digital identity, especially when the Swiss government have an EID, is every single application, even if you're logging into a shop, will say, can I have your Swiss ID to prove that you really are you? And you don't want to give your shop your real email to every single application in the world. Most times you want to surf on the internet without knowing who you are. Usually, I use a VPN everywhere now as well, and then I don't give you my proper password anywhere. Because everyone gets birthday wishes now. They have like 1,000 birthdays all over the year. And this is why did they want that information? It doesn't belong to them, so I never give it in correctly. So it's really cool. It's going to be really big. In the next 5 years, we're going to have to start using that soon, because if the government do bring this out, us as Swiss developers are eventually going to have to implement it on our applications as well as an alternative to OpenID Connect. So it's something I would learn it's really cool, but it's not complete. And it's like the early days of OAuth at the moment. But I think it's a cool tech. Any other questions? We've got 1 minute left. I have some cool examples as well for self-sovereign identity if you want to have a look at it. Azure verifiable credentials stuff. There's also, if you want to take part, the Swiss government have an open community now where you can ask questions and they answer you in French or German or English or Italian if you send it. And as I say, they do meetings once a month to explain what they're doing, which way they're going, because they have to create a trust anchor and a trust definition, because it's going to be the top level of this, and every single verifiable credential will probably use the Swiss EID. And they don't know, eventually you'll have a wallet issued from the government, and then you'll be able to use that wallet then with a Swiss EID, and then you'll be able to use that to log into every other application, especially for government and for things. Okay, so I'm told I have to stop. So I'll be around till just after lunch. I'll probably head off. And then if anyone has any questions or want to see examples, or just ping me and then I'll send them to you. Or I'm on internet and Twitter, LinkedIn, all the usuals. But I don't answer straight away. Yeah, just give me a shout if you need to know anything or you have problems, or let me know if I can help you. So thanks, no.